Let's try another circuit now. We'll begin by drawing another 10-volt source. And this picture is also out of the notes. 3 resistors again. Now let's analyze how the circuit flows in this circuit. It comes out of the source. Notice between the source and point A there's no resistor in series with the source. This means that I'm not going to create a voltage drop across here. And if I put in another point here, B, A is connected to the top of the voltage source, B is connected to the bottom of the voltage source. So these 2 points, A and B, are directly in parallel with the 10-volt source. So I'm going to have 10 volts across resistor 1, and I'm also going to have 10 volts across the combination of resistor 2 and 3. Back to the current. Comes out of the source, gets to point A. There's 2 paths for current flow. One path is through resistor 1, the other path is through resistor 2 and resistor 3. Notice this current, it goes through resistor 2 and resistor 3. These are series resistors. Starting furthest away from the source, again this is with R3, I can write my equation. R3 is in series with resistor 2 this time, and that combination is in parallel with resistor 1. If I substitute the values, 3K plus 2K in parallel with resistor 1, I get 5K in parallel with the 1K, which comes to 833.33 ohms. Now when I redraw my circuit, I'm just going to redraw the equivalent resistors as a 5K resistor, and this is still R1, 1 kilo ohms and 10 volts. Here's my point A, point B. So I have 10 volts across resistor 1 and 10 volts across the equivalent resistor. So knowing that, I can write V1 is 10 volts. Now looking for I1 is V1 over R1, so it's going to be 10 volts divided by 1K, or 10 milliamps. I'll get it yet. There we go. Okay, V equivalent. V equivalent is also 10 volts. So if I look for the branch current, which I'll call I equivalent, it's going to be V equivalent divided by R equivalent. Substituting my values, I get 10 volts over 5 kilo ohms, which is 2 milliamps. That means I have 2 milliamps right here, down through R equivalent. So I've calculated the voltage across resistor 1, I've calculated the current through resistor 1. Now if I want to break apart the parallel combination, I can draw my V equivalent voltage here, which is the source voltage is equivalent because again they're in parallel. I'd replace it with R2 and R3. Here's the I equivalent that I found. Resistor 2 had a value of 2K, resistor 3 had a value of 3K. To calculate the voltage drop across resistor 2, now remember, because resistor 2 and resistor 3 are in series, they're each going to have their own voltage drop. It's not going to be the 10 volts. The 10 volts is dividing between the 2 resistors. So V2 is equal to I equivalent times R2, which is 2 milliamps times 2K, or 4 volts, and V3 is I equivalent times R3, which is 2 milliamps times 3K, or in this case it's going to be 6 volts. I can use Kirchhoff's voltage law between that series branch of V equivalent is equal to V2 plus V3, and my Kirchhoff's current law equation is going to be total current is equal to I1 plus I equivalent, and those work out.